Hello to everyone, especially to the students who enrolled in differential calculus this semester. Please join with me to study this topic in differential calculus, exponential function by differentiation. So I have here, v is equals to e raised to the t all over by square root of 1 minus e raised to the negative 2t. Find dv dt. Okay? So, take note, this is quotient rule, QR. So, I will differentiate dv over dt is equals to, I will square the denominator. So, this will be square root of 1 minus e raised to the negative 2t squared. Okay? Then, I will copy the denominator, square root of 1 minus e to the negative 2t. Then, differentiate the numerator. Derivative of e to the t, that will be 1 e times e to the t, then minus, copy the numerator, e to the t, then differentiate the denominator. So this will be, take note, square root of x, that will be equivalent to x to the 1/2. So this will be 1/2, circle brackets 1 plus e raised to the negative 2t, then this will be negative 1/2, because 1/2 minus 1 is equals to negative 1/2. Then derivative inside the circle brackets, derivative of 1, that will be 0, then derivative of e raised to the negative 2t, so this will be negative, okay, this will be, I will use this one, negative 2, then e raised to the negative 2t. Okay? So I will use braces in here because I already use square brackets and then circle brackets. So we know the three groupings, braces, brackets, and circle brackets. Okay? So this will be square root of 1 plus e raised to the negative 2t times e to the t minus, okay, so this will be e raised to the t, then I will use square brackets, so this will be 1 over 2 circle brackets 1 minus e raised to the negative 2t raised to the negative 1/2. Then this will be negative, that will be positive, so this will be positive 2 e raised to the negative 2t, close, and then this will be over, so take note, this will be crossed out. So I have now circle brackets 1 minus e raised to the negative 2t. Okay, to simplify this one. So e raised to the t times square root of 1 minus e raised to the negative 2t, then minus. Okay, so the 1/2 will be crossed out with 2. So I have now e to the t. Then this will be circle brackets 1 minus e raised to the negative 2t raised to negative 1/2. Then this will be e raised to the negative 2t. Then this will be over circle brackets 1 minus e raised to the negative 2t. Okay? So allow me to erase this portion for my further solution because I have only limited space on my whiteboard. So this will be e raised to the t power, and then square root of 1 minus e raised to the negative 2t, then minus e t, and then times e negative 2t. Then take note, this is negative, so I will place below the bar line. So this will be 1 minus e raised to the negative 2t raised to positive 1/2. And then this will be over circle brackets 1 minus e to the negative 2t. Okay? Then I will simplify this one. So, I will do this one as e t square root of 1 minus e raised to the negative 2t, then minus e t, then times e to the negative 2t, then this will be over square root of 1 minus e raised to the negative 2t. Okay, then this will be over circle brackets 1 minus e raised to the negative 2t. Okay, so I will do something to make it single form. So this will be square root of 1 minus e raised to the negative 2t. I think I will erase this one. Okay, this will be LCD will be square root of this one. 1 plus e raised to the negative 2t. Then this will over 1, right? Divide and then times. So this will be e raised to square root, that will be, I'll just write for square root. Square root of 1 minus e raised to the negative 2t times 1 minus e raised to the negative 2t. Then minus this one divide by 1 minus 2 square root. This will be e t and then times e negative 2t. Okay? Then this will be all over by circle brackets 1 minus e raised to the negative 2t. Okay? So then multiply. Okay, so I have now e t and then square root. So 1 half plus 1 half, that will be 1. So this will be 1 minus e raised to the negative 2t raised to 1, right? And then minus e t times e to the negative 2t. Okay, then this will be over square root of 1 minus e raised to the negative 2t. Then all over by circle brackets 1 minus e raised to the negative 2t. Okay, so common for the numerator. Allow me to erase this portion. So common is e raised to the t. Then this will be 1 minus e raised to the negative 2t. And then this one will be minus, right? Then minus e raised to the negative 2t. Okay? Then this will be square root of 1 minus e raised to negative 2t. Then is all over by circle brackets 1 minus e raised to the negative 2t. Okay? So take note, there is 1 in here, right? Then I will simplify this one to make it single fraction. So for the numerator, this will be e raised to the t. And then this will be 1 minus 2, because e to the negative 2t minus e to the negative 2t, that will be negative 2e raised to the negative 2t. Then this will be square root of 1 minus e raised to the negative 2t. Then it's all over by 1 minus e raised to the negative 2t over 1. Okay, to simplify, this will be e raised to the t, circle brackets 1 minus e raised to the negative 2t over square root of 1 minus e, 1 minus e raised to negative 2t, then times, I will change this one to multiplication, then upside down, this will be 1 over circle brackets 1 minus e raised to the negative 2t. So, this will be e raised to the t, then circle brackets 1 minus 2e raised to the negative 2t, and then this will be 1 minus e raised to the negative 2t raised to 3 halves. Why? Because this is 1 half and then 1. 1 half plus 1. Okay? So LCD is 2. 2 divided by 2, that is 1 times 1, 1. Plus 2 divided by 1, that is 2 times 1, 2. So this will be 3 halves. Okay? So this is 3 halves. So then I will write the final answer. So my final answer is dv over dt is equal to e to the t and then 1 minus 2e to the negative 2t, then all over by square root of circle brackets 1 minus e raised to the negative 2t, then this will be cube. This is now my final answer. I think that's all. A friendly reminder, if you have questions regarding to my discussion about exponential function by differentiation, you may write your comment or comments at the comment section. Then, if you agree with me, please like and share, and do not forget to subscribe to my YouTube channel, Franz Maths TV. Thanks for watching.